Good afternoon, students. So, in the last class, I focused regarding this CYP, that is cytochrome P450 monooxygenase enzyme. So, how this particular enzyme which is involved in the mechanism, that is, which are all the gene which is responsible for this expression, which leads to the three phenotypic phenotypes which we have discussed, that is extensive metabolizers, that is EMS, which have functional enzyme activity, and intermediate metabolizers, that is IMS, is called, which is having diminished enzyme activity, whereas poor metabolizers, which is having little or no activity. Almost 5 to 10% of this Caucasians and the 1 to 2% of Asians, which is going to exhibit the PM phenotype, right? So let us now move on to the next concepts, that is substrate and inhibitor and inducer. What will be the effect of this substrate, inducer and the inhibitor molecule on the cytochrome P450 monooxygenase enzyme? So substrate, first coming to the substrate, which is an agent which is going to metabolized by an enzyme into a metabolic end product. Of course, if you are reacting some enzyme with a substrate molecule, which leads to the formation of enzyme substrate complex, right? That is a complex which is going to be formed and metabolic end product, which is going to be excreted. So once after reacting with the substrate molecule, so you are going to result with the end product that has to be excreted out from the body, right? So what about the inhibitor action here? So an agent which interferes with the ability of a given enzyme to metabolize a given substrate, which leads to the rapid increase in the level of the substrate concentration. So you can see here, so this inhibitor molecule which is going to react, compete with the substrate molecule for the site to act on that particular enzyme, that is maybe allosteric site or competitive inhibitor we can call it as. So it is going to metabolize, which leads to the rapid increase in the level of the substrate molecule, right? So this how the inhibitor which shows its ability to react with the enzyme for its active allosteric site, on the allosteric site of an enzyme. Coming for the inducer, so this is an agent which causes an increase in the production of an enzyme which is responsible for metabolizing a given substrate, which leads to gradual decrease in the blood level of the substrate. So you can see this particular reaction which is going to happen in 1 to 3 weeks. So what is going to happen? So this inducer molecule, if you are reacting with the enzyme, so which causes an increase in this production of the enzyme, which further leads to the metabolizing with a given substrate molecule, sorry. So the substrate is going to react with this particular inducer, right? So this is responsible for increasing the production of the enzyme, which is responsible in turn for the metabolizing of the given substrate, which leads to the gradual decrease in the blood level of this substrate molecule, because it is going to interact with the more of the substrate molecule, because more production of the enzyme. So this is going to happen in 1 to 3 weeks. This how the substrate inhibitor and the inducer which is going to act on this particular cytochrome P450 monooxygenase enzyme. So what will be the drug patterns, that drug interaction patterns we will see. So in case of pattern 1, that is an inhibitor which is added to a substrate molecule. If you are adding the inhibitor to the substrate molecule, for example, paroxetine. Paroxetine is an added to a nortriptyline, which leading to an increase in the nortriptyline blood level. So further, so what will be the inhibitory activity? So what is going to happen in the pattern 1? So if you are adding the inhibitor to a substrate, in the last slide you have seen what is going to happen if you are adding inhibitor to a substrate molecule, right? So here paroxetine is added to a nortriptyline. So here paroxetine is going to act as an inhibitor, is added to the substrate, leading to an increase in the substrate blood level, right? You are going to see the substrate which is going to be seen here. The rapid level of the increase in the blood level of the substrate is going to be observed here. In the pattern 2, that is the substrate which is added to an inhibitor. Example, so nortriptyline is added to a paroxetine. So you are adding a substrate molecule. This is a substrate. Nortriptyline is added to a paroxetine, that is a inhibitor. So which leading to an higher than the expected blood level of the nortriptyline at a given dose. So you are giving particular dose of the concentration of the particular drug. Even then it is showing the high level of that expected, more than the expected level of this nortriptyline substrate level in the blood, right? So this how the drug interaction which is going to happen in the pattern 1, pattern 2. If you're coming for the pattern 3, So here, what is going to happen? An inducer which is added to a substrate molecule. So what will be the action of the inducer on a substrate? So for example, if you are taking carbamazepine, which is added to the haloperidol, which leading to a decrease in the haloperidol blood level. So you are going to see here the inducer will be carbamazepine, which is added to a substrate, that is haloperidol is acting as a substrate, which leads to a decrease in the haloperidol blood level. So you are going to observe the rapid decrease in the substrate level, in the substrate level concentration in the blood. So coming for the pattern 4, what is going to happen? You are adding the substrate to the inducer. So here alloperidol is acting as a substrate which is added to the carbamazepine, which is leading to a, that is acting as an inducer. So which lead to a lower than the expected blood level. So you are going to see the blood, what expected level, more lower than the expected blood level of this alloperidol, that is the substrate at a given dose. You are fixing the particular dose or the concentration, then you are injecting, even then you are going to observe the expected level lower than the expected level of this alloperidol, that is the substrate molecule, substrate in the blood level, substrate concentration in the blood. So coming for the pattern 5, what will be this reversal of inhibition if it is going to happen? So an inhibitor and a substrate have been stably co-administrated, and then inhibitor is discontinued. So it is going to first it will be acting and stably, and then inhibitor is going to be discontinued. For example, cimetidine is discontinued in the presence of nortriptyline, leading to a decrease in the nortriptyline blood level. So what is going to happen? Nortriptyline was acting as a substrate there, right? So here what is going to happen? Cimetidine, which is an inhibitor, which is discontinued in the presence of this substrate, which leading to a decrease in the substrate level concentration in the blood. That is going to happen in the case of reversible of inhibition. This is the pattern 5. Coming for the pattern 6, what is going to happen in the pattern 6? So the reversal of induction is going to happen. Here an inducer and a substrate which has been stabilized and co-administered. Then you are going to administer to a body of an organism or human being, and then you are going to see that the inducer is going to be discontinued. For example, if you see in case of a patient on clozapine abruptly discontinues smoking, leading to an increase in the clozapine blood level. So it is going to discontinue the smoking in case of the patient. So which leads to an increase in the clozapine level. That is, the clozapine is acting as a what here? You are going to this clozapine is going to act as an inducer, right? So this going to be discontinued. Inducer going to be discontinued smoking, which leading to increase in the clozapine blood level. So it leads to the further increase in the concentration of this clozapine in the blood. So this will be the level of the pattern. In case this is the reversal of induction which is going to happen. So if you come for the particular role of this P450 monoxidase in the drug metabolism, if you see has a role. So this P450 in the metabolism of this endogenous substances, I have already explained you in the last class, endogenous compounds, which was elucidated. So in the metabolism of these exogenous compounds also, particularly drugs, natural products, and even other compounds which were also being discovered, it is now recognized that P450 are involved in the metabolism of most of the pharmaceutical compounds in the humans. That is, P450 is 3A4, 2D6, 2C9, IA2, 1A2 and 2C19 performs the majority of the drug metabolism, with some contributions from the P450s, 2E1, 2A6, 2C8 and 2P6. So we will see what are all the notable inducers and inhibitor substrates molecules acting on this particular enzymes, that is 3A4, 2D6, IA2, 1A2, 2C9, 2C19, 2E1 and 2B6. So you can see here 3A4. Notable substrates which are acting on this particular enzymes are that is alprazolam, triazolam, and as well as ampiprazole, carbamazepine. Just now we have seen that activity, primoside in the pattern, pymoside and quetiapine and spiridone, as well as tertiary as well as zolpidem, zolpidem, right? So these are all the notable substrates which are going to act on this particular enzymes. So if you come for the inhibitors, which are the notable inhibitors which are going to act on this particular 3A4 enzyme? So azole antifungals, ciprofloxacin, fluoxetine, grapefruit juice, HIV protease inhibitors, macrolide antibiotics, azithromycin, methadone, and fazodone. So these are all the notable inhibitors which are going to act on that. So you have seen the substrates and the inhibitors which are acting on that particular enzyme. So if you come for this 3A4, notable inducers, barbiturates, carbamazepine, modafinil, and oxcarbazepine, as well as phenobarbital, phenytoin, and ritonavir, and as well as St. John's wort and topiramate. All these are going to have a notable inducers on this particular enzyme. So coming for the notable substrates on this 2D6 enzymes, amphetamines, beta blockers, codeine, morphine, hydrocodone, hydromorphone, and phenothiazines, and TCS, and tramadol, and venlafaxine. So these are all the substrates, notable substrates which are acting on 2D6. Notable inhibitors, if you come across, bupropion, and cimetidine, and duloxetine, and fluoxetine, and paroxetine, and quinidine, and ritonavir, and sertraline, and TCS. So approximately sertraline will be greater than 150 mg per deciliter, which is going to work this particular inhibitor on 2D6 enzyme. Coming for the known inducers which have been noticed till now 2D6 on 2D6, possibility dexamethasone and rifampin. These are the notable inducers, no known inducers which are going to act. Coming for the notable substrates on the IA2, caffeine, clozapine, cyclobenzaprine, and olanzapine, probably several other typical antipsychotics are going to act on IA2 enzymes. Coming for the notable inhibitors, caffeine, cimetidine, fluoroquinones, and fluoxamine, and grapefruit juice are going to act on IA2. These are the inhibitors of this IA2. Coming for the notable inducers, cruciferous vegetables, broccoli, Brussels sprouts and cauliflowers, carbamazepine, and modafinil, and rifampin, and tobacco smoking. These are all the notable inducers on case of this IA2. Coming for the notable substrates are 2C9, glipizide, and phenytoin, and warfarin, THC. Coming for the notable inhibitors on 2C9, cimetidine, fluconazole, fluoxetine, etc. are going to act as notable inhibitors on the 2C9. So inducers same way on the 2C9, carbamazepine, phenobarbital, phenytoin, rifampin. See, you can make out almost all the inducers and inhibitors are going to work on the same on the enzymes, same inducers somewhere, and some where same notable inhibitors also working on the particular enzymes, right? 2C19 also notable substrates, diazepam, phenytoin, and tertiary amine, TCAs. Whereas 2C19 notable inhibitors, you can see many of these. 2C19 also carbamazepine, phenobarbital, phenytoin, rifampin. Notable substrates on 2E1, acetaminophen, ethanol. Notable inhibitors will be disulfiram and isoniazid. Inducers on 2E1, chronic ethanol use isoniazid, obesity, and retinoids, tobacco smoking. So notable substrates will be bupropion and cyclophosphamide and tamoxifen are going to act as a notable substrates on 2B6. Notable inhibitors on 2B6, fluoxetine, fluoxamine, and these paroxetine and sertraline. Notable inducers will be phenobarbital, phenytoin, and rifampin. All these are going to act as an inducers on 2B6 and inhibitors on 2B6 and 2E1 and 2C19 and all. So what we have seen till now, notable inducers, inhibitors, and substrate molecules. So how these are going to act on this particular enzyme to carry out the drug metabolism. So coming for in case of this P450 inhibition of a drug, which we have noticed in the last class itself, the plasma concentration of another drug which is going to greatly increase, which leading to possibly causing severe side effects or even death, right? So a classic case what we have seen in the inhibition of P453A4 by azoldrox and erythromycin, which resulted in decreased metabolism of this terfenadine and some deaths due to the arrhythmia. So because of this drug which is leads to a arrhythmia, some death which is going to happen because of this arrhythmia. So if this drug which is required at first, you are going to label about these concentrations, but subsequently terfenadine was withdrawn and replaced with its metabolite fexofenadine. So there is Allegra which does not have these issues. Particular issues which is going to cause will not be noticed in if you are replacing with this drug with this metabolite. So furthermore levels of this drug metabolizing P450 we can consider among individuals, whereas those involved in the metabolism of endogenous substrates generally do not. So this knowledge helps to see that partially different response, differential response from the individual to the drugs at different level. In addition, P450, 2D6, 2C9 and 2C19 involved in drug metabolism also displays common polymorphism or differences in the amino acid sequence, which produces altered and usually lowered enzyme activity. So these polymorphism in case of these enzymes, which can therefore lead to the poor drug metabolism, further leads to the severe side effects with the drugs which are metabolized by these 3 P450s. With this knowledge, we can see that some pharmaceutical companies are going to be very cautious in the development of these drugs, which are known to interact with the with these P450s monooxygenase enzyme system. So coming for this role of this P450 in chemical toxicity, how this is going to act. So which is involved mainly in the metabolism of pharmaceutical chemicals. So we can see the primarily this primary catalyst for this metabolism of other foreign compounds, which includes natural products. Even in the last few classes we discussed so far, pollutants and even other chemicals, which we can see many of the P450s which is involved in the drug metabolism are also the same 450s involved in the metabolism of the other xenobiotic chemicals also, which we can come across the oxidation of these compounds, which is beneficial for the removal of hydrophobic potentially toxic chemicals. In some cases we can see the oxidation of this P450 which can also result in the production of a toxic metabolite. So this for example, if you come across carcinogen, which is chemical carcinogens including polycyclic aromatic hydrocarbons, which will result in the incomplete combustion. So heterocyclic amines from which is this charbroiled meats, for example, aromatic amines such as dyes, pesticides, tobacco smokes, pharmaceuticals, nitrosamines, tobacco smoke and diet, which are formed from nitrites and nitrates and nitropolycyclic hydrocarbons from the incomplete combustion, which are going to be transferred to their carcinogenic forms by the P450 enzymes. In this case, a model in this model which we can come across, the chemical carcinogen which is converted by a P450 into a biologically reactive intermediates. I have already discussed this regarding this. It is going to convert active into active, active into inactive, inactive into sorry, active and inactive into inactive only. So these biologically reactive intermediates which are going to be formed usually, which is called as an electrophile, such as an epoxides, hydroxylamine and acyl halides example, etc. So these reactive intermediates which are short lived, which are able to become covalently attached to these nucleophiles further, which is carrying the negative charge, so such as found in the proteins maybe, and lipids or DNA molecule which is causing the cell damage. So the particular scavenging system such as glutathione molecule, what we have seen in the last class, conjugation process, that conjugate with the electrophile. See, the conjugation is the main thing which will see the particular conversion of this particular active to inactive, and it will be converted and it will be excreted out, right? So the scavenging system such as glutathione, once after the conjugation, that conjugates with the that is going to conjugate with the electrophiles and reduces the toxic effect of this reactive metabolite, which will further can be depleted in the presence of high doses of this electrophile, right? So because some chemicals which can be activated to a toxic or carcinogenic products via this P450 oxidation by P450 monooxidase enzyme. So we can see here one of the interest factor or the thing which we can notice here, the developing inhibitors of P450s which as chemopreventive agents. Such inhibitors which have long been known to be able to prevent acute toxicity or even the cancers in the experimental animal models. So precedence exists in the use of these inhibitors P450R 19A1, which converts androgens to estrogens as therapeutic agents in the treatment of estrogen dependent tumors in case of some tumor treatment. And the drug Multipraz can block the activation of the mycotoxin aflatoxin B in case of humans, although inhibition of these P450 has potential in chemopreventive strategies, the application is very limited. So whatever the particular inhibitory action which is going to happen and even the activation of this drug but this application which is still very limited, in very limited condition, so they have so far not applied to this particularly. So this is how this particular P450 monoxidase enzyme system, which is going to act on this detoxification mechanism in order to convert active into inactive toxic chemical, toxicity will be reduced and further it will be excreted out of the body. This how it plays a very important role in the detoxification mechanism. This completes complete xenobiotic and endogenous substance and cytochrome P450 monoxidase enzyme mechanism. Still, if you are having any doubts, please you can call me or ask the questions. You can ask the doubts through messages. Thank you.